All right, quiz tomorrow, sections 3.5 and 3.6. This is, I don't know why I did this, but I only made 5 questions on this. Probably because there wasn't really enough stuff to do to get 10 questions out of it, because it's only just a few little things you have to know how to do. So maybe that's why I only made 5 questions. So we'll keep it at that. I was thinking about making it 10, but we'll just do the 5, because really none of these are like long involved problems. Most of the time when I give you a 5-question quiz, usually it's because the problems take so long, it'd be hard to do 10 of them. So we'll just go through what I have on this quiz. So number 1 on the quiz is like section, so this is over section 3.5. So number 1 on the quiz, okay, is like section 3.5.
Are you recording that?
Yes. Numbers, let me just double check, make sure. Yes. Like, let's see, 12 to 15. I actually gave you a really easy one. Okay? So if you look at section 3.5, numbers 12 to 15, number 1 on the quiz looks very, very similar to that. And the question is, determine whether the function is continuous at the given x value. So, for instance, let's just say number 12. Let's just take a look at number 12. This is not exactly the one that's on the quiz, but it's kind of like it, all right? So they're going to give you a function, y equals x cubed minus 4. And they're going to say, is it continuous at the point x equals 1? So basically, if it's continuous, it has to exist, all right? And when you put that 1 in for that, you will get a corresponding y, whatever that is. So if you graph this thing, and I'll let you use Desmos. I'm letting you use Desmos on this quiz, and on this test, I'll let you use Desmos. But you cannot sneakily get on there and go to some AI thing and snap a picture of it and get an answer for it, okay? You can only use Desmos, and that's it. Everybody understand that? All right, and I'll walk around. I'm going to be looking, all right? So you can only use Desmos, and that's all. So what you would do is you would graph this thing. So let me change this to Desmos so that I can see. On this one, it's easy enough to graph, but let's just do it anyway. So what I say was y equals x cubed minus 4. Okay, so y, let's just use this thing, equals x cubed, and then minus 4. All right, so there is that. Let's lower that thing. And basically what I want to do is look at x equals 1, and let's zoom it up a little bit, x equals 1. Does this graph exist at x equals 1? X equals 1, right there. It has a y value attached to it, doesn't it? It's got a negative 3. So yes, it does exist, all right? So there's no hole or anything like that. It does exist. And if I put in a 1 in for this, does it give me my corresponding y value? So what is the y value right here? If I get right on it, it's 1, negative 3. So does it actually work? If I put a 1 in for this, 1 cubed is 1, minus 4 is negative 3. Yes, it does. And that's basically how you do these. There's that 3-step thing. But if you do those, if you just see that it does exist, and that if you put the x value in, because it says at x equals 1, so I put a 1 in for this, do I get the same corresponding y value as this graph is? Yes, it does. So I'm good to go. Does that make sense? Yeah. I picked an easy one, but the rest are kind of like that. What's a common one that doesn't exist? Like it would not be a function. What would it kind of look like? Let's go back to this Illustrator. What's a situation where, one that's very common, that it would not exist? What if you had like 1 or y equals, let me find one. I'll just do number 13. Again, this is not exactly the one on the quiz, but you could see something very similar to it at x equals 2. Is this continuous at x equals 2? It's not, because if I put a 2 in for this, okay, 2 minus 2 is 0. Can I divide by 0? So it doesn't exist to begin with. All right, so I don't even care what the graph looks like. I don't have to graph it. I just look at this and I say, if I put a 2 in for this, it is not continuous because it does not exist at x equals 2. Does that make sense? You could put it in a graph, and that's going to give you that asymptote. Remember that? It's going to give you that dot. Desmos doesn't give you a dotted line, but it will not exist at that point. All right, so that's kind of what you're looking at. So that's number 1 on the quiz. All right, let's do another one. Number 2. So number 2 on the quiz looks like it's still section 3.5. It's the end behavior stuff. So 20 to 25. So it's section 3.5, numbers 20 to 25. So if you look at those problems, the one on the quiz, number 2 on the quiz, will look like these problems right here. All right? And the problems say, find the end behavior. So let me just find one. Let's just do number 20. Let's just do 20. Okay, so this is 20 from the homework. It's y equals x cubed plus 2x squared plus x minus 1. All right. How do I know what the end, and it says find the end behavior. Find the end behaviors. All right. You don't necessarily have to go to Desmos to do this, but let's do it just so we can see what it's going to look like. Everybody good with that? All right, so let's go back to Desmos. And let's graph that. Let's see, so what is it? Y equals x cubed again? Plus 2x squared, so let's see, x cubed plus 2x squared plus x minus 1 plus x minus 1. Okay? And there we go. So how do we write the end behavior? Well, what is that left end behavior doing? As this goes to negative infinity, as x goes to negative infinity, to the left, where is the y going? To negative infinity, isn't it? Just keeps on going and going, right? I could keep going and going, and it's still going to go down. It's never going to turn back up again, all right? So as x goes to negative infinity, so you put x arrow, right? Put an arrow to negative infinity, comma, then what does y do? Y goes to negative infinity. Everybody see that? So what's the other end of this graph? As x goes to what? Positive infinity, what is this graph doing? Then y is going to positive infinity. All right, now does every graph do that? No, just graphs like this. Now, did you really have to put this in Desmos to find the end behaviors? You really didn't. What was the key to this graph right here to know what the end behavior was? Right, the largest exponent, which is x cubed. So this acts like a regular x cubed function. So you should know what the x cubed function looks like right off the top of your head, don't you? Right, that's one that we've done a lot. So the green one is your, I'll just call it your normal, everyday, it's like the parent function, right? We talked about that. It's It's your normal everyday y equals x cubed function. So it acts, that blue one, even though you got all that other stuff in there, the 2x squared, the x, and the minus 1, even though you have all that, the end behavior is going to be exactly the same. Does that make sense? Okay, so you really did not have to go through the trouble of graphing this on Desmos and looking at the end behavior of that one because it acts the same as this one does. All right, so really, you could almost like show no work for that at all. Just write down as x goes to negative infinity, then y goes to negative infinity. As x goes to positive infinity, then y goes to positive infinity. All right, just because you know this blue one is going to react the same way as far as the end behavior. Now, it does some other stuff in between, doesn't it? Look, it kind of goes up like this, then it comes down, then it comes back up again. This doesn't do that, but the end behavior, that's all we're worried about right here, the end behavior is exactly the same. Does that make sense? All right. So it sounds confusing and it sounds weird and all that, but really not that difficult. All right? All right, let's go back to this. And let's look at the next one. So number 3, this is the increasing, decreasing. So this is still section 3.5. So number 3, it's still section 3.5. But it covers numbers 26 to 31. So if you look at 26 to 31, you're writing this down, aren't you? All right, that's going to be number 3 on the quiz. All right, so let's do one of those. Determine whether it's increasing or decreasing. Yeah, we'll just do the first one again, which is number 26. So let's write that down. Y equals x cubed plus 3x squared minus 9x. Now in this one, you're going to want to graph this thing, all right? Now, are you going to graph this like just on paper in your head with tables and all that? No, you're going to use Desmos to graph that. One day, Owen, one day. Just come in here and stay in here the whole period. That'd be really nice. One day. Maybe that'll happen. Maybe it won't. All right, so let's graph this thing right here and take a look at it. Again, what are we doing? We're finding the intervals that it's increasing and decreasing. All right, I'll just write that in there. Increasing. Where is it increasing? And where is it decreasing? All right, so let's graph this thing. Did you guys write this down so I remember? Because I won't remember that. So let's change this back to that. All right, let's get rid of these. Oops. There we go. All right, so what was it? Y equals what? X cubed plus 3x squared. All right. Okay, y equals x cubed. Should have just kept that other x cubed up there, couldn't I? Plus 3x squared plus 3x squared. And then what? Minus 9x. Minus 9x. There we go. All right, let's zoom out a little bit on that. There it is. Okay. All right, so where is it increasing? So from left to right, if I'm moving from, right, if I have a little car there, right, and I'm moving from left to right going this way, where is this graph increasing? From negative infinity, good, right, because if you keep on going down, see this, as going from left to right, this gets higher and higher and higher, doesn't it? As I move to the right. So it's increasing all the way until you get to where? Well, to the top of that. Where is the top of that? Well, let's put a little point there. You can put a point there. It goes to -3. All right, it's a little stretched out, but you put the point there, and that's -3. So we're increasing from negative infinity to -3. Okay, or you could say, I think the book writes it. The book writes it x is less than -3, which is the same thing. You could go either way. Everybody see that? So here's -3 right there on the x-axis. It's increasing everything to the left of -3. Or you could say, and I'm fine with either way, you could say it's from negative infinity to -3. That's where it's increasing. Is it increasing anywhere else on this graph? It is. Okay. Now this part right here is not. What's it doing here? That's decreasing. But then it starts increasing again. It gets down to this point right there. Let's get exactly where it is. 1, -5. And so from, how would you write this? You could say anything x is greater than 1, or you could say it's increasing from 1 to infinity. Right. So from 1 to infinity, it's increasing because, again, it keeps on going up and up and it never turns back down again. You with me on that? So it increases in two places. Anything less than -3 and anything greater than +1. Right? Or you could do the infinity thing like we said. Where is it decreasing? Well, it's just the stuff that's in between. From where to where? It's decreasing. Again, we're talking the x-axis. It's decreasing from -3 on the x-axis, that would be right here, okay, all the way to where? To +1, right, if I can get it, there. Anyway, you get the idea. It's close to 1. It's hard to get it to stick right on there. All right, and that's your intervals, and that's how you would write something like this. All right, so looking at your graph is super important. That's where you can tell if it's increasing or if it's decreasing. Make sense? Yeah, again, pretty easy. It's kind of weird stuff. It's not like the normal math that you think of, but that's what we have to see. All right, that's all for section 3.5. Now we're going to go to section 3.6. And that's the stuff we've been doing lately here, just the last couple days. So we got 2 more to do, and both of these are going to be on there. So number 4 on the quiz, I'm going to give you a graph. So number 4 on the quiz, it's like section 3, oh, sorry. Yeah, it's 3.6, that's right. And let me find what numbers I gave you to do. And that would be like 13 to 18. So I actually give you a graph. So you don't have to graph it. I'll put a graph right on the quiz. And it's going to be something like 13 to 18. And again, I'll just do the first one. I'll just do number 13. I'm just going to do a little rough sketch of this thing. And let's make this a different color. All right. So it looks just like an upside down parabola. 1, 2, 3, 4. So it's -4, 1. So 1, 2, 3, 4, 1. Starts here, and it goes like this. And it goes like that. Well, the top of it's right there. Okay, I kind of went above a little bit, but you get the idea, right? All right, so that's the top right there, -4, 1. All right, so what are they asking you to do? They're asking you to find the extrema, okay, of this. It says name and classify the extrema. So you tell me which one is the critical point, right, the extrema, and tell me where it's located. And that's what they're asking you to do. I already gave you where it's located. But on the quiz, it'll actually be a graph and you can count over and up and all that kind of stuff. But I just did that for you on this. So what is this? That's our critical point. That's our extrema right there. Okay, what is that? That's a what's the word? It's an absolute maximum. You got it. So it's an absolute maximum. And where is it located? Because the question says name and classify. So we named it. This is the name of it. When I say I classify it, means where is it? All right, where is it located? At -4, 1. All right, that was an easy one because there's only one of them. I'll tell you right now, the one on the quiz will give you something like this. Okay? I think. Yeah, it looks something like that. Now, I didn't put where the points are, but where are this would be a what? This would be a maximum, but it would be a what? A relative maximum, all right? Because remember, it's not the highest point on the y-axis at all. It keeps on going up here. So it's not the absolute maximum. That would be a relative maximum. What would this be right here? So it'd be a relative minimum. All right, then you just tell me where the points are located. And on the graph, it'll have the little grid sheet thing on there, right? You can count over and up and all that kind of stuff. So that's what the one on the quiz is going to be more like. We good? Yeah.
Are you going to take points off if you don't write relative or absolute?
Yes. Yeah, you got to be specific. All right. So on these, you absolutely have to be specific. Okay. So it's absolute or relative. Everybody good?
Yeah.
Okay. All right. One more, and then it's like the last thing we just collected today. So again, you can graph it. So number 5 on the quiz, it's like section 3.6. Numbers, let's see, 26 to 33. That's the ones we talked about today. All right? And so it says determine whether the critical point is a maximum, minimum, or a point of inflection. So let's do one that's not the first one. Let's do 27. So 27 on the homework, that's one of these. It's y equals -x squared plus 8x minus 10. And you want to see, at the point x equals 4, is that a maximum, is it a minimum, or is it a point of inflection? So where do you go to do that? Go to Desmos, all right? And let's put that in there. All right, so it's y equals, remember, -x squared plus 8x, so it's, negative 8x squared. Is that what it was? No, it's just -8 squared. I have the worst memory ever known to man. -x squared plus 8x minus 10. Yeah.
Somebody offered you $1 billion to drink if you do it.
To do what?
To drink alcohol.
Drink what?
Alcohol if you do it.
What? Why is that? Why?
He said you don't drink. Yeah.
To take one drink?
To like.
Absolutely. Are you offering it?
What about for 100 guys?
Why in the world did that pop up in your mind? All right, let's take a look at this. All right, here we go. So so here's our graph right here, and we need to see the points. What did I say? X equals 4. All right, so you come over here to x equals 4. My guess is it's probably right there. It sure is. There it is. So what is that? There we go, 4, 6. That's our point right there. Everybody see it? Okay, so is it a maximum? Is it a minimum? Is it a point of inflection? Easy, it's a maximum. Where is the point? It's at 4.6. They don't even ask you that. Determine whether they don't even ask to find the point. They just say, is it a maximum, minimum, or a point of inflection? Super easy. This might be the weirdest math stuff that you've done so far in your math career, but this quiz itself may be one of the easiest quizzes that you're going to do. You know what I mean? The matrices are weird. Yeah, this is kind of weird, but this is stuff that you would not do in Algebra 2 that you're going to use a lot of this stuff in calculus, all right? So this is more pre-calculus than any of the other stuff that we've done before. All right. Is that good? Yeah, I think that's good. All right, so quiz tomorrow, and then we'll start. Let's say we got, how many more lessons do we have? I think we only got like one more lesson, 2 more. Yeah, we got 2 more lessons. We'll take another quiz after those 2 lessons. Then I'm thinking we could have a test on it. I don't know. I'll have to look to see what I did last year. I don't know if I included that on. I think we did take the test, and then we took the midterm. So yeah, that's what we'll do. All right. So yeah, I think we got plenty of time to get a quiz and the test in. I don't know. I'll have to look and see. So I can't say for sure right now, but I will look and see. Okay, enough of that. We're done.